When we're picking injectors for a high-performance fuel injection project, there's several things that we have to consider. One is the physical dimensions of the injectors so that they fit the intake manifold and the fuel rail and the injector connector. There's several different connectors out there, US card, Delphi, different Japanese connectors. We can use different injectors in our application or fills our horsepower needs, but we may have to use some injector adapters. We also want to make sure about injector targeting. We wouldn't want to use a two-valve injector which it has a targeted spray pattern for two intake valves and a multi-valve application when it's a single valve application. So there's several things that we have to consider. Now, as far as injectors go, there's basically two different types. There's injectors known as peak hold and injectors known as saturated. A peak hold injector will have a resistance of approximately 1 to 4 ohms and it will draw approximately 4 amps. A saturated injector will have a resistance value of 12 to 16 ohms and will draw right around 1 amp. They are not interchangeable. The driver circuitry inside either the factory computer or the aftermarket computer has to be matched to the injectors. Now, there are some aftermarket engine management systems in the performance world where you can tell the computer which type of injector you're using and it will adapt or switch driver channels internally. But most factory computers, you have to pick the right type of injector electrically, whether or not it's a peak hold or a saturated injector, to match the factory computer. Back in the 80s and 90s, this was a bit of a problem because the biggest saturated injector we could get was around 42 pounds an hour. So if you needed a larger injector for your usually a forced induction application, turbocharged or supercharged, if you needed an injector larger than 42 pounds, you had to use a special injector adapter box that would get the driver channels correctly oriented to the resistance and the amperage draw. Since then, in the last 8 to 10 years, we have injectors that are saturated up over 1,000 cc's or over 100 pounds per hour, so that's not a problem anymore. When we're talking about injector flow rates, when we say, hey, you need a 24-pound injector, you need a 30-pound injector, you need a 550 cc injector, remember that the ratings are based on 43.5 psi. So if you have a 24-pound injector that is rated that flow at 24 pounds per hour at 43.5 psi, but you're putting it on, say, an LS-based engine in which the fuel pressure is 58 psi, obviously the injector is going to flow at a higher rate than the standard 24-pounder. You can always take the new pressure divided by the old pressure, then multiply that number times your injector flow rate in either cc's or pounds per hour and get the new flow rate of the injector based upon the increased pressure. It seems when we're discussing tuning an import vehicle, many of the tuners and the manufacturers that supply injectors will always give you the rating in cc's. When you're talking to a domestic tuner such as a GM, Ford, Chrysler, Dodge, Jeep application, they usually give you the injector flow rating in pounds per hour. Like I said earlier, it is based upon 43.5 psi. There's several calculators on the internet that you can use to convert cc's into pounds per hour or pounds per hour into cc's so you can get the right correlation if you're using a horsepower to injector flow calculator. There's several of these on the internet, and I highly recommend you utilizing these to determine your project horsepower. If you know that your project should be around 400, 450 horsepower, then go to an injector sizing calculator and make sure that you have the right size injector for the horsepower needs that you're going to have on your project fuel injected engine. Let's take a look at the requirements of an 8-cylinder engine at various horsepower levels. We also have to consider, is the engine naturally aspirated, turbocharged, or supercharged? And this falls into an area that you'll see your calculator will ask you, known as brake-specific fuel consumption. Most naturally aspirated engines will fall into an area of 0.5. If it's a really efficient fuel-injected engine, it may come in at 0.45, but 0.5 is a good number to use for naturally aspirated, 0.55 to 0.6 on supercharged and turbocharged applications. So if we look at the chart here, we can see that if we have an engine that's going to produce 300 horsepower, we're going to need a minimum of a 24-pound injector at a 0.5 BSFC, or brake-specific fuel consumption, on an NA naturally aspirated vehicle. Technologically speaking, injectors have come a long way. What I have here is a very popular injector widely used today. It's a 60-pound Siemens Deca injector. I call it a pencil style injector. It's a narrow, skinny injector. Typically they're black. Sometimes they've been copied and known as Mototrons or Siemens Deca. They either come in 60 or 80-pound varieties. And back in the early 80s and 90s, an injector that was 60 pounds was really hard to control at low RPM and idle, and it was hard to get really good idle stability. Technologically speaking, injectors are much more forgiving now, and they're easier to tune at idle and off-idle characteristics, and this is one of the injectors that does really well in this area. Another thing to consider, let's say that we have a mechanical return style system with an FMU, or a rising rate fuel pressure regulator. There are some injectors out there that just won't take the pressure. For example, there were some earlier Rochester Multitech injectors back in the GM LT1 engines that if the pressure exceeded 65 to 70 psi, the fuel pressure would actually drive the injector closed. Well, this is not good in a forced induction or a nitrous application, because if we start to close the injector, we're putting in additional air either from the turbocharger or the supercharger or from the nitrous, and the injector's starting to close because it can't handle the higher pressure. The lightweight disc in the injector, or the ball and seat, is being driven shut. And that can be tragedy for the engine. If you go that super lean, you could actually melt or burn a hole right into the top of the pistons. So we also have to consider what pressures we're going to run and what pressures will our injector really like. These Siemens Deca style pencil injectors, these new Bosch style injectors also, the narrow bodied one, they really like pressures in the 55 to 70 psi range. That gives them the best atomization, discharge, and that gives us better idle quality, stability, fuel economy, all around just a better atomization of the fuel getting into the combustion chamber.